Olympiad Prep Guide 5 Science Chapter 4 Natural Resources and Indian Heritage. Resources that are present in the environment and have not been brought about by any human activity are called natural resources. These resources are useful for mankind. Natural resources can be classified as follows: renewable natural resources and non renewable natural resources. Renewable natural resources are available continuously in nature. Example: solar energy, wind energy, etc. Non renewable natural resources are available in limited quantities and may get finished up. Example: fossil fuels. The important natural resources are air, water, land, forests, fossil fuels, solar energy, wind energy, hydroelectric sources, mineral deposits, etc. The important natural resources are 1. Air, 2. Water, 3. Land, 4. Forests, 5. Fossil fuels, 6. Solar energy, 7. Wind energy, 8. Hydroelectric sources, 9. Mineral deposits, etc. 4.1 Air, water, and soil. Air and atmosphere. Air is present all around us. We cannot see it, but we can feel its presence. Leaves rustle, clothes sway on the clothesline. Branches of trees move because of the movement of air. A thick blanket of air that surrounds the earth is called atmosphere. The thick blanket of air that surrounds the earth is called atmosphere. It is a mixture of several gases, mainly nitrogen, carbon dioxide, oxygen, hydrogen, etc. The atmosphere makes the earth hospitable to all living organisms. It protects us from harmful ultraviolet rays, UV rays of the sun, and it also helps to keep the earth warm by trapping the heat of the sun. The atmosphere is held around the earth by Earth's gravity. The atmosphere is held around Earth by the Earth's gravity. The atmosphere is divided into 5 layers. 1. The troposphere. 2. The stratosphere. 3. The mesosphere. 4. The thermosphere. And 5. The exosphere. Tropo, strato, meso, thermo, exo. We live in the troposphere. Remember the Tropic of Cancer, the Tropic of Capricorn? Use them as mnemonics to remember that the first layer of the atmosphere is the troposphere. The troposphere is the first layer above the Earth's surface. All weather changes take place here. It extends up to 16 kilometers from the Earth's surface. Yes, the troposphere extends up to sweet 16 kilometers from the Earth's surface. If there's anyone among us who doesn't love the weather, we'll have to go above 16 kilometers into the next layer of the Earth's atmosphere, the stratosphere. The stratosphere is an important layer as it contains ozone gas that absorbs harmful ultraviolet rays of the sun, UV rays of the sun, and protects us from its harmful effects. It extends from 16 to 50 kilometers above the Earth's surface. Sweet 16 to half of 100, that is 50. 16 to 50 kilometers above the Earth's surface is the stratosphere. If you want to experience what the ozone layer feels like, go to the stratosphere. So you'll have to go above 16 kilometers but stay below 50 kilometers above the surface of the Earth. The next and third layer is the mesosphere. The mesosphere layer prevents small rocks and meteorites from reaching the Earth's surface. It extends from 50 to 85 kilometers above the Earth's surface. So the mesosphere is like a helmet of the Earth. It prevents small rocks and meteorites from reaching the Earth's surface. It extends from 50 to 85 kilometers above the Earth's surface. Let's recap the first three layers. The troposphere 0 to 16 kilometers from the Earth's surface, stratosphere 16 to 50 kilometers, mesosphere 50 to 85 kilometers. The fourth layer is the thermosphere, where many satellites and space shuttles orbit the Earth. It extends from 85 kilometers to 600 kilometers above the Earth's surface. So there's lots of space for lots of satellites and space shuttles to orbit the Earth over here in the thermosphere, which extends from 85 to 600 kilometers above the Earth's surface. So the thermosphere is a very, 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 very thick layer of the Earth's atmosphere. The exosphere is the fifth layer, EXOSPHERE. It is the outermost layer of the Earth's atmosphere. It extends from about 600 kilometers above the Earth's surface to the outer space. Where the troposphere ends and the stratosphere begins, this demarcation is called the tropopause. Where the stratosphere ends and mesosphere begins, that's called the stratopause. Where the mesosphere ends and thermosphere begins is called the mesopause. And where the thermosphere ends and the exosphere begins is called the thermopause. So we have the troposphere, the tropopause, the stratosphere, the stratopause, the mesosphere, the mesopause, the thermosphere, the thermopause, and then we have the exosphere, which extends limitlessly to outer space. What is the composition of air? 78% nitrogen, 21% oxygen, and 1% of other gases. 7-8% nitrogen, 2-1% oxygen, 1% other gases. There is 21% of oxygen in the air. Is that why everyone celebrates their 21st birthday? The air that surrounds us is a mixture of several gases. It contains about 78% nitrogen and 21% oxygen. The remaining 1% is made up of other gases such as argon, 0.9%, argon, 0.9%, neon, hydrogen, helium, ozone, and carbon dioxide, 0.03% only. 0.03% only of carbon dioxide. The remaining 1% is made up of other gases such as argon, 0.9%, neon, hydrogen, helium, ozone, neon, hydrogen, helium, ozone, and carbon dioxide, 0.03% only. Water vapor is also present in air. Air is humid when there is more water vapor in it. Air is dry when there is less or no vapor in it. The amount of water vapor in the air is called humidity, Humidity. It varies from place to place. Air also contains dust particles and smoke. Too much dust and smoke leads to air pollution. Smoke and fog combine together to form smog. Smoke and fog combine together to form smog. Smog affects visibility. Uses of air. Almost all living organisms need oxygen to survive. They take in oxygen from the air through the process of breathing. Oxygen also supports burning. Nitrogen is an essential nutrient for plants and other organisms, but they cannot directly use the nitrogen present in the air. They cannot directly use the 78% of nitrogen present in the air. Special bacteria in the soil convert the nitrogen in the air, the 78% of nitrogen in the air, into a form that can be used by plants. From plants, the nitrogen reaches other organisms. Nitrogen does not support burning, hence it helps in controlling fire. Oxygen supports burning. 21% of oxygen in the air supports burning. 78% of nitrogen in the air does not support burning. Plants need carbon dioxide along with water, minerals, and sunlight to make food. All other organisms either directly or indirectly depend on the food prepared by plants. Moving air is called wind. Wind energy is also a natural resource. Wind helps parachutes, gliders, and kites to move. It can push sailboats. Wind helps clothes to dry. Wind can also turn the blades of the windmill to draw water or generate electricity. Properties of air. Air is colorless, odorless, and is present everywhere. Odorless, odorless. That means it has no smell. Air occupies space. Air has weight. Yes, air has weight. Weight. Air can be compressed. Balls, tires, etc. have compressed air in them. Air exerts pressure. Air is needed for burning. Air expands on heating and rises up. Hot air balloons work on this property of air, that air expands on heating and rises up. Like the seven colors of the rainbow, air has seven properties. 1. Air is colorless, odorless, and present everywhere. 2. Air occupies space. 3. Air has weight. 4. Air can be compressed. 5. Air exerts pressure. 6. Air is needed for burning. 7. Air expands on heating and rises up. Properties of air. 7 properties of air. 1. Colorless, odorless, present everywhere. 2, 3. Occupies space, has weight. 4, 5. Can be compressed, exerts pressure. 6, 7. Needed for burning, expands on heating and rises up. MCQ time. Multiple choice question time. 1. In which layer of the atmosphere is ozone present? The stratosphere. 2. Which of the gas present in air cannot be used directly by plants and animals? Nitrogen. 3. Which of the gases present in air do not support burning? Nitrogen and carbon dioxide. 78% of nitrogen and 0.03% carbon dioxide. 4. Which property of air is used when you drink juice using a straw? Air exerts pressure. 5. The component of air used for making food by plants is present in what percentage in air? 0.03%. Carbon dioxide is the component of air used for making food by plants and is present in 0.03% in air. Water. Water is essential for life. About 70% of the Earth's surface is covered with water. It is present in oceans, rivers, lakes, ponds, etc. Water also exists in air as water vapor and under the ground as groundwater. Almost all activities performed by us require water. We need water for drinking, bathing, day-to-day household activities, irrigating fields, generating electricity, industrial activities, etc. It is necessary to drink pure water as impure water can make us ill. Rain is the purest form of natural water. Rain is the purest form of natural water. But rainwater, while falling down, can accumulate certain impurities from the air as well as certain living and non-living things. Therefore, it is necessary to purify water before drinking. Types of impurities present in water: soluble impurities and insoluble impurities. Soluble impurities are impurities that dissolve in water. Example, salt. Insoluble impurities are impurities that do not dissolve in water. They either float on the surface or settle at the bottom. Example, sand, mud, plastic bottles, etc. Separation of soluble impurities. Soluble impurities can be separated by evaporation and distillation. Evaporation or boiling. This is a very simple method of separating impurities like salt from water. Take impure water in a vessel and heat it. After some time, the water in the vessel turns into vapor and the impurities are left behind. By this method, we get the impurity left behind. Water is completely lost. Distillation. Distillation. Distillation is another water purification process. It is carried out in a special apparatus consisting of a round bottomed distilling flask, a water condenser, a receiving flask, and a burner. The round bottomed flask has the impure water. Below the round bottomed flask is the burner. We have the receiving flask. Connecting the round bottomed flask with the impure water and the receiving flask with the pure water, we have the condenser. The condenser looks like a pipe. In distillation, the contaminated water is heated until it starts boiling. This boiling water slowly changes into steam, leaving behind the impurities in the flask. The steam then passes through the condenser and gets cooled, thereby turning back into liquid water. This clean water gets collected in the receiving flask. This distillation setup is called the distillation unit. Olympiad bite. The solubility of water increases with increasing temperature. The solubility of water increases with increasing temperature. You try to dissolve some sugar in normal water and you try to dissolve the same sugar in boiling hot water. Which dissolves faster? The sugar in the boiling hot water will dissolve faster. Why? Because the solubility of water increases with increasing temperature. Separation of insoluble impurities. Insoluble impurities can be separated by methods of sedimentation, decantation, and filtration. Sedimentation and decantation. Settling down of heavy impurities at the bottom of a vessel is called sedimentation. Once these impurities settle down, clear water is slowly poured into another jar. This is known as decantation. Both these processes together are suitable for purifying water contaminated with insoluble impurities. So you let the insoluble impurities sediment down, settle down, and then you slowly decant the clear water into another clean container. I firmly believe it is so very important to be scientific and to learn a lot about science via observation and experiments as well. One day when I was making tea in the kitchen, I couldn't find the strainer. Then I remembered this process of sedimentation and decantation. I waited till the tea leaves settled down, sedimentation, and then I used decantation. I gently poured the tea into the cup, ensuring that no tea leaf entered my teacup. Filtration. The method in which impure water is made to pass through a filter paper to remove impurities is called filtration. Filter paper acts like a sieve, sieve, and does not allow impurities to pass through it. The impurities remain on the filter paper and the clear water is obtained. This technique, TECHNIQUE, this technique helps to remove very small impurities that are not removed by sedimentation and decantation. So one day I boiled filter coffee. And I said, let me use sedimentation and decantation. So I let the filter coffee settle down. After sedimentation, I decanted it. But then when I was drinking it, I did see very, 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 very fine coffee particles in it. That's when I reached out for the filter paper and I filtered my filter coffee using the filter paper to remove the very, 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 very tiny small coffee particles. So, to separate soluble impurities, we use evaporation boiling or distillation. To separate insoluble impurities, we use sedimentation and decantation or filtration. Water treatment plant. Water supplied to our homes is first treated at water treatment plants to remove impurities. Three methods are mainly used for treatment of water: 1. Sedimentation, 2. Filtration, 3. Chlorination. Sedimentation, filtration, chlorination. Thank you, God, for my lovely nation. Sedimentation. Water collected in large open tanks is left undisturbed for a few days so that the heavier suspended impurities sink to the bottom. Air and sunlight kill many harmful bacteria. Air and sunlight kill many harmful bacteria. Chemicals like alum, are also added to speed up the sedimentation loading. Filtration. After sedimentation, the water is filtered through a clean sand bed to remove finer suspended particles. 3. Chlorination. Water is then disinfected with a very small quantity of chlorine gas to kill bacteria. This water is now safe for human consumption. Sedimentation, filtration, and chlorination. Although the water supplied to our homes is properly treated, but it is still not very safe for drinking as it may have some dissolved salts, dirt, and germs. Purification of drinking water at home. Clean drinking water is a basic human need. Contaminated water can cause diseases. Therefore, water needs to be purified to make it fit for drinking. Water can be purified at home by the following methods: 1. Boiling, 2. Water purifiers, 3. Chlorination, 4. Filtration, 5. Sedimentation. 1. Boiling. It involves boiling water for at least 10 minutes. The heat in the water kills germs present in it. This boiled water can be cooled, filtered, and then stored for consumption. 2. Water purifiers. Many types of water purifiers are available for domestic uses like the RO purifier, that is the reverse osmosis purifier, the ultraviolet purifier, the UV purifier, the activated carbon purifiers, etc. Most common among them are water purifiers which work on reverse osmosis process. In this reverse osmosis process, the RO process, water is passed through a semi-permeable membrane or filtering sheet which removes impurities. It is a very effective process of water purification. Chlorination. Chlorine tablets or potassium permanganate crystals can be added in water to kill germs. Potassium permanganate is purple in color. When you put it in water, the entire water initially turns purple. 4. Filtration. Filters are commonly used at homes and contain one or two filter candles made of clay. These candles filter and remove insoluble impurities. 5. Sedimentation. Water is stored in a container and allowed to stand for some time. All the insoluble impurities settle down at the bottom. To speed up sedimentation, a piece of alum is put in the water. Alum particles get loaded with the suspended particles in water, which makes them heavy, and they settle down at the bottom. This process is called loading. Then this water can be decanted and used. So what is loading? Alum particles get loaded with the suspended particles in water, which makes them heavy, and they settle down at the bottom. This process is called loading. Loading. Soil. The uppermost layer of the earth's crust in which plants grow is known as soil. What is soil? It is the uppermost layer of the earth's crust in which plants grow. Without soil, there would have been no plants on earth. Soil helps plants to grow by holding their roots firmly, and it also provides water and essential nutrients to them. So, soil does three things: it holds the roots of plants firmly, it provides water to plants, and it provides essential nutrients to the plants. Soil is also home to a number of animals and microorganisms. Types of soil: sandy soil, clayey soil, loamy soil. Sandy soil. Sandy soil does not hold moisture as it has big air spaces between its soil particles. Thus, with water, all the other essential nutrients also flow away. Due to this, it needs regular addition of fertilizers. So, sandy soil needs regular addition of fertilizers. Why? Because it has big air spaces between its soil particles, and so when water flows away, all the essential nutrients also flow away from the sandy soil. Clayey soil. It is usually rich in nutrients. It can hold moisture and it has smaller air spaces between its soil particles. But it forms hard lumps when wet. It also develops cracks in hot weather, causing harm to the roots of plants. So, this wealth of the clay soil, which is rich in nutrients, comes at a price. It forms hard lumps when wet and it develops cracks in hot weather, causing harm to the roots of plants. Loamy soil, Loamy, loamy soil. Loamy soil can hold adequate moisture and is rich in nutrients. It is a mix of both sandy and clayey soil. Hence, it is best suited for plant growth. Composition of soil. Soil consists of a number of components, that is, humus, HUMUS, minerals, water, air, and soil particles. Gravel, sand, clay, etc. What are the soil particles? Gravel, sand, clay, etc. Soil consists of a number of components: 1. Humus, 2. Minerals, 3. Water, 4. Air, 5. Soil particles like gravel, sand, clay, etc. Living organisms, that is, earthworms, snails, insects, and other microorganisms like bacteria and fungi are also present in soil. Olympiad bite. Earthworms are known as farmers' friends. They bury deep in soil, turn it, and so make it loose. Their movement helps to bring the nutrients that are present deeper in the soil to the upper layers of the soil. This improves the fertility of the soil and helps in soil aeration, Aeration, aeration. So, why are earthworms farmers' friends? Because they help in aeration of the soil. Bacteria and fungi also help in the complete breakdown of dead plants and animals. This process releases the nutrients back to the soil, enhancing its fertility. Soil formation. Soil is formed by breaking down of rocks due to the action of wind, water, temperature, and microorganisms. Soil is formed by breaking down of rocks due to the action of wind, water, temperature, and microorganisms. Remember temperature. This process is called weathering. This process is called weathering, Weathering. What is weathering? Weathering is the process of formation of soil by breaking down of rocks due to the action of wind, water, temperature, and microorganisms. Formation of soil is a very slow and continuous process that takes not tens, not hundreds, but that takes thousands of years to complete. Soil is so beneficial for everybody. I want to become soil, said the earth's crust to God. Very well then, said God, wait 1,000 years. And so it is that those parts of the earth's crust that waited 1,000 years transformed into rich soil. Soil profile. The layers of soil are referred to as soil profile. The layers of soil are referred to as soil profile. These layers are horizons A, B, C, and bedrock. Horizon A, horizon B, horizon C, and bedrock. Topsoil or A horizon is the fertile layer of the soil. It contains humus mixed in soil particles, air, and water. Plants obtain nutrients from this layer, the topsoil or the A horizon. Subsoil or B horizon has water. The roots of plants may grow till here. It contains very less amount of organic matter. Sea horizon contains broken fragments of the parent rock from which soil particles form due to erosion and weathering. Water is scarce in this layer of the sea horizon or parent rock. Bedrock is a compacted and cemented layer of parent rocks. So the soil profile from top to bottom is A horizon or topsoil, the most fertile layer that contains humus. B horizon or subsoil that has water. C horizon or parent rock. And bedrock, the compacted and cemented layer of parent rocks. Soil erosion. Removal of the top fertile layer of soil by wind, water, or other factors is known as soil erosion. It results in loss of the top fertile soil. Loss of fertile soil makes the land unsuitable for farming. One day, at the farmers' meet, all the four layers of the soil, the A horizon, B horizon, C horizon, and bedrock, asked the farmers, "Whom do you like the most amongst the four of us?" Now, the farmers knew that each layer had their own part to play. So they all said, "We love all four of you equally." Just then, the children of the farmers whispered to the topsoil, "You know, topsoil, actually, our papas love you the most because if you disappear, our papas can farm no more." Causes of soil erosion: 1. Wind. 2. Water. 3. Deforestation. 4. Overgrazing and other causes. 1. Wind. Due to wind, a lot of topsoil is blown away. Especially in desert areas, strong winds carry a lot of sand with them and deposit them to far off places. 2. Water. Water as a cause of soil erosion refers to soil erosion due to rain and running water like floods, etc. Heavy rainfalls result in the removal of topsoil. This has worse effect in hilly regions. Water flows at great speed down the hills and loosens the particles of soil. This results in washing away of the nutrient-rich topsoil, making the land barren, barren. Moving water like a river flowing down a hill also washes away topsoil and mud along with it. 3. Deforestation. One of the main reasons for soil erosion is deforestation. Roots of the trees hold the soil particles together. In their absence, soil becomes loose and is easily carried away by wind or water. 4. Overgrazing and other causes. Overgrazing by animals also results in soil erosion. Forest fire and poor farming methods also cause soil erosion. Soil conservation. The process of soil formation is very slow. It takes hundreds of years to form an inch-thick layer of soil. It is necessary that we must protect the soil from getting eroded away. To prevent soil erosion, we must follow the given practices. 1. Afforestation and reforestation. Planting more trees in new areas is afforestation. Afforestation. Planting more trees in new areas, that is afforestation, or deforested areas, reforestation, is the most efficient way of reducing erosion. Trees break the flow of wind and water. Trees break the flow of wind and water. Afforestation is planting more trees in new areas where there were no trees before. And reforestation is planting trees in forested areas that were deforested. 3. Plant covers. Farmers must grow trees or hedges around the fields to break the flow of wind. In the period between harvesting and sowing of new crop, the soil is left bare and loose. Farmers can grow grass in the field or cover the land with dried vegetation. Harvesting takes time. So while we are harvesting, the soil is empty, it is barren. So planting some plants over there just till you can sow is called giving a plant cover for soil conservation. 3. Terrace farming. The slope of hills can be cut in steps. This slows the flowing water. Terrace farming done on these steps helps in reducing soil erosion. 4. Embankments. Building embankments along the river banks prevents soil erosion caused due to the running river water. What is an embankment? An embankment is a wall of stone or brick built at the river bank to stop the river from flooding over and thereby eroding the soil. Thank you, Lord, for the air we breathe, for the water we drink, and for the soil that grows our food.